Hello students, this is Anupal sir. Welcome to my channel. Today I am going to discuss most important topic for competitive purpose from coordination chemistry class 12, that is crystal field theory, CFT. Actually, I am thinking that I will make a series of videos of any chapter. Okay, so coordination chemistry, already I have uploaded the valence bond theory part. I have already made how can you predict the structure of coordination complex from any given question. Here, I will make video for its IUPAC name, for isomerism, and in this video I am going to discuss crystal field theory. I have seen that someone has written in the comment section, sir, please make a video on that. Okay, so let's start. If you watch my video of valence bond theory, then you can see that which one is strong field ligand, which one is weak field ligand. I have just quick revision of that. Okay, I am just making a quick revision of that which one is strong field ligand. Strong field ligands are Cn minus, carbon monoxide. I have already made a video of heteronuclear diatomic molecular orbital diagram. Okay, so in this case, if you see the MO diagram of Cn minus, MO diagram of Cu, then you can see that all of them are sigma donor, pi acceptor. Sigma donor, pi acceptor. So they are known as strong field ligand. Strong field ligand, ethylene, diamine also. Okay, so all these ligands are basically strong field. EDTA, obviously EDTA, one of the example of strong field ligand. But weak field ligands are those like F minus, Cl minus, Br minus, I minus, H2O. Ammonia is considered as moderate field because for some metal it is acting like strong field, for some metal it is acting like weak field. It has also a proper logic. Chemistry is not a subject only to Maga. Okay, so every exceptional has proper logic. We need to find out the proper reason. So if we just see the example of MnCN whole 6 3 minus, I have already told you in my valence bond theory video that Cn minus or CO, if strong field ligands are present, then number one, electrons are to be paired up. Inner orbitals are to be used. And as electrons become paired, so magnetic moment will be low. So they are known as diamagnetic or weakly paramagnetic. And they are low spin complex. They are low spin complex, spin multiplicity, or they are low spin complex. Clear? But if we consider about high spin complex, that means the characteristics which we have found in case of strong field ligand, that will be just reversed in case of weak field ligand. So if weak field ligands are there, then what is going to happen? Just opposite phenomena will be going to be happen. Like electrons will not be paired, they will be high spin complex, their magnetic moment will be higher, and they don't have that capacity to form bond of or to fill the electrons in the inner orbitals. They will fill the electrons in the outer orbital. If you watch the valence bond theory coordination chemistry part, you will understand all these things. Clear? Now, this valence bond theory have some disadvantages. It gives us idea regarding the hybridization part which one will be sp3, which one will be sp3d2, that is outer orbital complex, d2sp3, that is inner orbital complex, dsp2, that is square planar complex, but does not give the idea regarding the splitting of d orbitals. Splitting. But CFT gives us that idea. Okay, so in case of crystal field theory, we need to assume some things. They are, number one, the central metal atom and the ligands are basically, their interactions are basically purely ionic in nature. No coordinate bonding, purely ionic in nature. Ligand will give the electron, metal will accept it. Got it? Ionic spheres purely ionic in nature, interaction. And crystal field theory gives us the idea regarding the splitting of d orbitals. Splitting, I will show you right now. Splitting of d orbitals. And gives the exact value of magnetic moment, or we can predict which one is paramagnetic, which one is diamagnetic. Okay, so let us consider, if we have this example in our hand, then we can see that Cn minus 6 minus, Cn के लिए 1 minus है, 6 के लिए कितना होगा 6 minus, and Mn should be plus 3 here. Mn should be plus 3 here, isn't it? So Mn, you know, you can check the electronic configuration part. This is very much important. Mn has the electronic configuration argon 18, 3d5, 4s2. So if Mn 3 plus is there, then it should be argon 18, 3d4 and 4s0, because 3 electrons are to be removed. 4s2 or 3d1, 3d4 one here. So 3d4, and it is strong field ligand. That means no unpaired will be there. 3d4, 5 orbitals it has. So in case of if Cn minus is there, then no unpaired will be there. Magnetic moment will be 0. Magnetic moment का formula क्या था? Root over n into n plus 2. Bohr magneton. N is the number of unpaired electrons. So from VBT, we can have that there is no unpaired electrons. But actually, it has magnetic moment root 8. That means N should be 2. N should be 2. Okay, so we can explain all these things on the basis of CFT. So our topic is actually crystal field theory today, which can be classified for two parts. One is for octahedral, that is it may be the hybridization sp3d2 or maybe d2sp3. अगर strong field ligand है तो d2sp3 inner orbital complex, अगर weak field ligand तो sp3d2, no problem with that. And another one is our tetrahedral. Another one is our tetrahedral, and hybridization would be sp3. Okay, coordination number 4, and in this case coordination number is 6. So let's start CFT of octahedral part. I have told you some important thing regarding that. D orbitals basically are classified as dxy, dyz and dzx, and dx square y square, dz square. These three are along the planes, and these two are along the axis part. They are spread over like that. प्लेन क्यों? क्योंकि xy प्लेन पे है. Say for example xyz, we have written here. Say for example xyz, x y z. So you will have like that. प्लेन के ऊपर, dxy means this one, so dyz means y and z plane के ऊपर, dzx means z और x plane के ऊपर. Is it clear? So these three are along spread over the plane, so their energy levels are same. When splitting would be there, their energy levels would be same. And this is the x square y square part. Look at that. They will be along the axis. Dx square y square, if it is x, if it is y, and if it is z. Dx square will be looking like that. Dz square, if it is z axis, it is x, it is y. Okay, if it is z axis, then the mixing of d orbital will be looking like that. So this is known as dz square spread over the axis. This is also spread over the x axis, y axis. That is why it is dx square y square. Clear? So in तीनों energy level same, ये दोनों energy level should be same. Now come to this part, sp3 d2 or d2 sp3. Which d orbitals are used? D orbitals are used dx square y square dz square. I will show you now. dsp2 जब स्क्वायर प्लानर होता है, ये क्या होता है? ऑक्टाहेड्रल. This portion is for octahedral. This portion is for square planar. उसमें कौन सा d orbital used होता है? dx square y square. Okay, and sp3d or dsp3, that is the trigonal bipyramidal structure sp3d. In that case, dz square orbital is used. Clear? This is octahedral structure. So when ligands are approaching towards the central metal atom, they are approaching like that. In this side, this side, this side, this side, this side, this side. So in this case, in this case, in this case. So like that, the orbital, the d orbital, which are spreading over or along the axis, they will be more affected, isn't it? So ligands are basically approaching in the octahedral field along the axis. So the orbitals which are spread over along the axis, they will have higher energy because they will feel more repulsion. उसका एनर्जी ज्यादा हो जाएगा जो d orbital axis के ऊपर था. इसलिए the spreading of that orbital would be energy not in scale. I have written here, suppose d orbital ground state level, where all dxy, dyz, zx, x square, y square, z square, all are degenerate ground state. लिगैंड अभी आया नहीं है. जब लिगैंड आएगा तो उसका एनर्जी क्या होगा? That would be in excited state. It is in excited state, isn't it? You have to write all these things over here also. Now, spreading should be there. The d orbital which are spread over along axis, that means more repulsion it will face, that means it will have higher energy level. So in this case, this is the ground state, this is the excited state, and when ligands are approaching, they will spread like that to the orbitals which are over axis. They will be in the higher energy level, and the orbitals which are spread over along the planes, they will be in the lower energy level. And this is known as the average part. This is known as the barycenter. ये कुछ ऊपर चला गया, कुछ नीचे चला गया, तो एवरेज जो होगा that is known as barycenter. Clear? And for the axis, the orbital which are spread over along the axis, for that each value, each orbital के लिए value will be 0.6 delta O, delta octahedral, and 0.4 delta O for each plane. प्लेन के अलोंग जो है, प्लेन के ऊपर जो है, उसके लिए each रूम के लिए वैल्यू कितना होगा 0.4, because 0.4 into 3 you will get your answer. 0.4 into 3 कितना होता है 1.2, that is minus 1.2, and 0.6 into 2 कितना होता है 1.2, that is plus 1.2, because ये ऊपर है ये नीचे. Got my point? So now come to the Mn Cn whole 6 3 minus part, where Mn is 3 plus, isn't it? So Mn 3 plus मतलब क्या सिस्टम है? अभी कुछ देर पहले बोला था 3d4, तो 3d4 का मतलब क्या होगा 1 2 3 4, 1 2 3 4 नहीं, यहां पर 4, क्योंकि स्ट्रॉन्ग फील्ड लिगेंड. अगर वीक फील्ड लिगेंड होगा तो इलेक्ट्रॉन विल बी अनपेयर्ड, अगर स्ट्रॉन्ग फील्ड लिगेंड होगा तो इलेक्ट्रॉन विल बी पेयर्ड इन नेचर, isn't it? So that's why how many unpaired you will get? You will get 2. That's why mu value would be root over n into n plus 2, so root 8 more magneton. I think I have made myself clear, isn't it? So it is paramagnetic, obviously, though it is strong field, but it is paramagnetic in nature. How many unpaired? 2. So दोनों के लिए spin multiplicity का वैल्यू कितना होगा? Spin multiplicity का वैल्यू है 2s plus 1. इसके लिए plus of, so 2 into 1 plus 1, that would be 3. Because plus of actually 1, so this value should be put here and its value would be 3. Got my point? So this is for octahedral part. What is the CFAC calculation? CFAC. What is the calculation? CFAC calculation would be 4 into room के लिए वैल्यू कितना था? So minus 1.6 delta O. Crystal field splitting energy or crystal field stabilization energy, which we can't get from valence bond theory. Got my point? So this is the factor. And if it is diamagnetic, then no electron should be unpaired. It is unpaired, 2 electrons unpaired, that is why it is nature, it is paramagnetic in nature, isn't it? So अगर strong field ligand होगा तो splitting ज्यादा होगा. Okay? अगर weak field ligand रहेगा तो यहाँ पर 4th electron नहीं रहेगा, यहाँ पर आ जाएगा 1 2 3 4, because weak field ligand causes unpairing. I hope it is clear. Now come to our next part, that is when the compound is in coordination number having 4 and it has tetrahedral structure. Tetrahedral structure, for that tetrahedral structure splitting is less because only 4 ligands are there. Say for example Mn Br4 2 minus, तो यहाँ पर Mn कितना होगा 2 plus, इसका मतलब क्या सिस्टम होगा 3d5. So if coordination number is 6, then it will be octahedral. If coordination number is 4, it can be square planar, it can be tetrahedral. That depends on ligand. Is it clear? So in this case, in the tetrahedral field, just the opposite diagram we need to draw. Okay, because of, look at the thing first of all, then I will give you the trick. This is ground state. We have to write here dxy, dyz, dzx, dx square, y square, dz square. All these are given. This is excited state. Okay. Now the splitting would be just reversed. So dx square, y square, dz square will be in the lower part. xy, yz, zx will be in the higher part. And this is the barycenter, you know. The values are same, 0.4 delta t and 0.6 delta t. Got it? So why the orbitals along spread over the along the planes, they are in the higher state? Because of, look at that, Mn Vr4, the ligands are coming. This is the axis, you know. This is the axis. This is one axis. This is one axis. This is another axis. Okay. So the ligand basically the ligand comes here in between the axis. That means the space in between the axis they are coming. Is not it? And in between the axis, look at that. In between the axis, which portions are there? The orbitals along these planes, spread over the planes, they are present. So that's why ligands are coming from this part along the planes. So the orbital which are spread over along the planes, they will feel more repulsion. That is why it would be in higher position. Okay, so if you draw the diagram, you can understand this. Now 3D5 system, follow this part 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2 here and 3 here. Weak field ligand. So 2 here, 3 here. No problem with that. It will follow always the Ohm's rule part. If the ligands are strong field, then also it will follow the Ohm's rule principle. Got it? So crystal field theory, in short, the concept of octahedral splitting, the concept of tetrahedral splitting, and why crystal field theory is needed, you can get your answer. What is the calculation? 0.6 into 2. This is minus 0.6 into 2 plus 0.4 into 3. The answer will be 0. So in this case, CFSE would be 0. Got it? Here. So for more videos, please subscribe to my channel, and if you think that it is to be liked and shared, please do it. Have a nice day.